Lesson 3. Database Service Tier Sizing. When you deploy Azure SQL, you have three different options to choose from. Let's go through them now. The three main options that you have are SQL databases, SQL managed instances, and SQL virtual machines. SQL virtual machines is the infrastructure solution. It's going to be most similar to deploying a virtual machine in the cloud rather than on-premise. You're going to be selecting the operating system and the version of SQL Server that you're going to use to manage that machine. SQL Managed Instances is the platform solution, where there is a single instance that is going to be lift and shift ready for a migration in the cloud, but you're not managing the operating system. SQL Databases is the software as a service solution, where you're going to be just deploying a database by itself and sizing appropriately. Let's move into a little bit more detailed, starting with the SQL virtual machines. When you select SQL virtual machines, it's going to ask you the basics of creating it as well as selecting a virtual machine size. You'll notice at the top, the disks, networking, management, those are all very similar to actually creating a virtual machine. And in fact, other than the SQL Server settings, it's almost exactly similar. For the service tier options, there's going to be a general purpose and business critical. In both cases, you can choose between 4 and 80 virtual cores. Besides the storage amount, the primary difference between general purpose and business critical is whether or not you're going to have a lot of I/O intensive or compute intensive workloads. For SQL databases, when you select a single database, you are going to have 6 different options to choose from, 3 of which are going to be the database transaction unit model, and the other 3 are going to be the virtual core model. The question becomes, do you pick the DTU or database transaction unit model or the virtual core model? The virtual core model is probably something you're already familiar with. You're going to choose the compute and storage resources that gives you the flexibility, control, and transparency of how much information is getting transferred to your actual virtual machines. The database transaction unit is going to be a little different, but it's actually very useful as far as bundling storage, compute, and I/O. Moving into this a little bit further, the database transaction unit, or DTU, represents all of the resources assigned to that database. So CPU, memory, read writes, all of them are going to be bundled and simplified in order to talk about overall utilization. So instead of talking about how much CPU, how much memory, how much read and write that the SQL Server is getting performed, we just simplify it down to DTU. For the DTU model, we have basic, which is less demanding workloads, a standard environment, which is really typical performance requirements, and then premium, which is I/O intensive workloads. The vCore model is going to have a general purpose, which is scalable compute and storage, hyperscale, which is going to be on-demand scalable storage, and the third one is going to be business critical, which has a high transaction rate and high resiliency. Let's explore these a little bit further, starting with the DTU model. The main difference between each of these models is the DTU and the data max size. Basic for DTU is 5. As you move to standard, it's 10 to 3000, and then premium is going to be 125 to 4000 DTUs. The other side of this is the data max size, which starts at 100 meg for each one of the different DTU models. And then as you move up, it starts at 2 gig as a max, standard is 250, and premium is 1 terabyte. For the vCore model, what you need to determine is how many IOPS, the latency, the amount of cores, and the data max size. Hyperscale is essentially an option for using data science. The data max size is 100 terabytes versus the 1 gig to 4 terabytes available because of that big data analysis requirement. And as an aside, general purpose actually has a serverless option as well. The next piece is about elastic pools. Now, this is a way in order for you to manage and scale multiple databases, as well as use a pool of resources for multiple databases so that you could respond to varying and unpredictable demands. It's going to be very similar to putting a hypervisor onto your on-premise environment, where you can make a series of virtual machines, but they all share the same load as what's on the hypervisor. You can specify a lump sum of resources that you need, and you can actually apply them to each of the different databases that you control. For elastic pool sizing models, we have the eDTU model. And just like before, there is a basic, standard, and premium model into that pool for all of your databases to use. For basic, you can pick up to 5 different databases. For standard, you get up to 10, and premium, you get 25. The vCore model is also similar to the single database sizing models where we have general purpose, hyperscale, and business critical. You'll also notice that all of the different latency and IOPS, vCore, and data max sizes are exactly the same as in the traditional single database vCore model. The only difference here is whether or not you're applying it to an entire pool or to one specific database. For SQL databases, I've talked about a single database and an elastic pool, and there's a third option there, which you might be wondering, what the heck is that? Database server. The database server is a logical container for managing all of the databases and elastic pools that you have. It does not have an additional charge whatsoever. So when you go inside of a database server, you'll actually see that you have the ability to create databases and pools, and you'll be able to manage all the databases in a similar fashion as normal database administrators do. You can also see that it provides security and monitoring, automation, and performance tuning and recommendations as well. So, as a quick review of all of the different plans available for Azure SQL, we have that SQL virtual machine where you're going to essentially own that entire virtual machine, the image and the version of SQL Server. You also have the SQL managed instances where you're going to choose between single instances or elastic pools, but you still have a little bit more control over exactly how that is managed. And then finally, SQL databases, which is the full software as a service solution that has serverless options available.